Hello friends, I welcome you in lecture number 14 on normal distribution. In this lecture, we will discuss one question on normal distribution which was asked in GTU Summer 2025 examination. Now we are familiar with normal distribution. We have discussed 13 lectures on normal distribution which you can watch if you have not seen them before going for this lecture, and we are using normal probability tables to calculate probabilities related to normal distribution. So you must be familiar with the use of normal distribution also, that you can watch in lecture number 2 and 3. There I have explained the use of normal distribution tables in calculating probabilities. And we also recall that if x is a normal random variable with mean mu and variance sigma square, then z equal to x minus mu over sigma is a standard normal random variable, and probability tables for normal distribution give us the probabilities which are related to this standard normal random variable. So whenever our random variable is not standard, we will standardize it using this expression z equal to x minus mean over standard deviation denoted by sigma. So with this in mind, we try to answer this question which was asked in GTU Summer 2025 examination. First we understand what is given and what we have to find. We are given that weight of 1000 experimental animals is normally distributed with mean 235 grams and standard deviation equal to 35. How many animals weigh below 172 grams, above 312 grams, and between 172 and 312 grams? That is, we have to determine the number of elements whose weight is below this number 172. We have to find out the number of elements whose weight is above 312 grams, that is greater than 312 grams, and we have to determine the number of elements whose weight is in this interval 172 to 312 grams. So first we will calculate the probabilities related to these three, A, B and C, and we will multiply these probabilities by total number of elements, which is 1000. Before that, here it is already given that weight of animal is normally distributed and mean and standard deviation are given. So first we consider capital X, which is our normal random variable, equal to weight of an animal. Here it is given that weight of animal is normally distributed, and we are also given the values of mean and standard deviation for this normal random variable. It is given that mean equal to 235 grams and standard deviation is 35. Mean is 235 and sigma is 35, and we are given that this weight is normally distributed with this mean mu equal to 235 and variance or standard deviation sigma square equal to square of 35. And using this information, I have to first find out the probability that animal has weight which is less than 172 grams. So first I will calculate the probability that weight of an animal is less than 172. So I will calculate this probability for part A, and to determine the number of animals having weight below 172 grams, I will multiply this probability by number of animals, which is 1000. So first we try to answer part 1. Here we first determine the probability that weight of animal is below 172 grams, and because we have used capital X to denote the weight of an animal, we can express this as weight of animal is below 172 grams, that is probability that capital X is less than 172. And we know that we are not having table values for this normal random variable X, so we will standardize it. For that we subtract mean on both sides and we divide by sigma on both sides. So these two are equivalent statements. We can rewrite X less than 172 as X minus mu over sigma is less than 172 minus mu over sigma, and this is our standard normal random variable Z equal to X minus mean over standard deviation, and here we put values of mean and standard deviation, which are given as 235 and 35. And if I calculate this quantity, this turns out to be minus 1.8. And to calculate this probability, I will use normal probability table. We are having two types of normal probability tables. We have already discussed about that in earlier lectures. Here we are going to use probability table which gives us the area between 0 and Z. We are going to use this type of normal probability table to calculate this probability, and you can see here I am going to use this probability table. So here this area is nothing but area between 0 and small z. So all these values in the table are nothing but areas between 0 and z. For example, this value 0.0832 is nothing but area between 0 and 0.2 plus 0.01, that is 0.21. This probability is corresponding to this z value that we can write as 0.2 plus 0.01, so that is nothing but 0.0832. So that is how we use this probability table to calculate the probabilities involving standard normal random variable. So here we are given this type of probabilities, area between 0 and z, and this is not in this form. So we have to rewrite this probability in such a way that we can use this normal probability table. So for that we can simply use this symmetry of the graph. We are familiar that this is the standard symmetric density curve. In the center we have 0, and suppose here somewhere I have z equal to minus 1.8. On this horizontal axis we have values of small z, and I am interested in this probability that z is to the left side of minus 1.8, and by the symmetry of this density curve we will have somewhere here 1.8. So if we use the symmetry, then we can see that these two areas are equal. Area to the left of minus 1.8 is equal to area to the right of 1.8. So this I can rewrite as probability that z is greater than 1.8, because I want to express this probability in this form: 0 less than capital Z less than small z. So for that first I am using this symmetry. So now I am interested in this probability, that is area to the right of this 1.8. Now we know that area to the left of 0, that is this area, probability that z is greater than or equal to 0 or strictly greater than 0 is 0.5. That is area to the right of 0, this area to the right of 0, this total area is 0.5, and we are interested in the area to the right of 1.8. We are interested in this much area. So that area is equal to this total area to the right of 0, which is 0.5, minus area between 0 and 1.8. So this I can rewrite as this is equal to probability that z is greater than 0 minus probability that z is in between 1.8. Okay, I repeat again. Area to the right of 0, total area to the right of 0 is 0.5, and we are interested in this area. So this area can be obtained by subtracting this much area from total area to the right of 0, and we know that this is nothing but 0.5, and this we can obtain using the table for normal probability. So here I require that area between 0 and 1.8, so that I can obtain from this. To use this table, we are interested in this area between 0 and 1.8, that is small z is 1.8 here, so that we can search in the column below these z values. So here I have z equal to 1.8, and 1.8, that is 1.8 plus 0.00. So I have to search below 0.00, and in this row I will search in the row corresponding to z equal to 1.8 and here 0.00. So I obtain this value. Okay, this area between 0 and 1.8 is 0.4641. So this is my required value. Probability that z lies between 0 and 1.8 is 0.4641, that I will substitute here, 0.4641, and using these two values I find that required probability is 0.0359. This is the probability that weight of animal is below 172 grams, and we are interested in the number of elements whose weight is below 172 grams. Therefore, the number of animals whose weight is below 172 grams, that we can obtain by multiplying this probability that x is less than 172, that we have obtained, that we multiply by total number of elements, and we will find that 0.0359, and this turns out to be 35.9, and this we can round off up to 0 but decimal places as 36. So we can say that approximately 36 animals are having weight below 172 grams. So this is first part. In second part we have to find the number of animals whose weight is above 312 grams. So first we calculate the probability of weight which is greater than 312 grams. Probability that weight of animal is above 312 grams, that we can write that capital X is greater than 312 grams. Again we have to standardize, so for that we subtract mean on both sides and we divide by standard deviation on both sides. X minus mu over sigma is z. Here 312 minus mean equal to 235, and this is 35, and if I calculate this quantity, that turns out to be 2.2. So I am interested in the probability that z is to the right side of this value 2.2. So Suppose approximately this is standard normal density curve. Somewhere here I have 2.2 and I am interested in this area. Z is greater than 2.2, that is area to the right of 2.2 is the probability that Z is greater than 2.2. So here also we are applying the same logic. We know that area to the right of 0 is 0.5 and we are interested in this much area. So this much area is area to the right of 0 minus this area, and this area is nothing but probability that Z lies between 0 and 2.2. So this I can write directly. I will subtract this much area from the area to the right of 0, which is 0.5. I will subtract this area. To calculate this area to the right of 2.2, I will subtract this much area from 0.5. So here I write 0 less than Z less than 2.2. And to obtain this probability, we again use this table, standard normal table. Now we have to search for 2.2. Now Z is 2.2. So we have 2.2 here, and we can visualize 2.2 as 2.2 plus 0.00. That means we have to search in the column below 0.00 and row corresponding to 2.2. So we have this value 0.4861 is the probability that Z lies between 0 and 2.2. So that we substitute here 0.4861, and this turns out to be 0.0139. So this is the probability that weight of animal is above 312 grams, and to write down the number of animals, we will multiply this probability by total number of animals. The number of animals whose weight is above 312 grams, that is equal to 1000 multiplied with this probability, which we have denoted by probability that X is greater than 312, and that is obtained as 0.0139, and that turns out to be 13.9. and if we round off up to 0 decimal places, we have 14. So there are 14 animals approximately whose weight is above 312 grams. So this is part B, and in part C we have to determine the number of elements whose weight is between 172 and 312 grams. So now we consider part C. We have to find the probability that weight of animal is between 172 and 312 grams. So that we can express as between 172 and 312 grams, that is X lies between 172 and 312 grams. And now we standardize, we subtract mean and divide by sigma. So this is 312 minus mu over sigma, and we have already calculated all these values. 172 minus 235 divided by 35 less than Z less than 312 minus 235 divided by 35, and we have already calculated all these values in part A and B. Here this quantity is minus 1.8, and for 312 it is 2.2. So that means Z lies between minus 1.8 and 2.2. And now we have to calculate this probability using standard normal table, and we can use part A and B also. We have obtained the required values. Suppose this is 0, here somewhere I have minus 1.8, suppose 2.2 is somewhere here. So area between minus 1.8 and 2.2 is nothing but sum of these two areas. Area from minus 1.8 to 0 and area from 0 to 2.2. So let me write this as minus 1.8 less than z less than 0 plus 0 less than z less than 2.2. Now if you observe, this area is due to symmetry. If you consider, suppose 1.8 is somewhere here, then area between minus 1.8 and 0 is equal to area between 0 and 1.8 due to symmetry. So I replace this by area between 0 and 1.8 because I am having table values for this type of probabilities or areas. So I have used symmetry, and this is area between 0 and 2.2, and we have obtained both the values in part A and part B. In part A we obtained the area between 0 and 1.8, that was 0.4641. so we can directly substitute here. This is 0.4641 plus area between 0 and 2.2 is 0.4861. This is 0.4861, and let me add these two. I am having all the calculations. So this is going to be 0.9502. So this is the probability that weight of an animal is between 172 and 312 grams, and we are interested in the number of animals whose weight is between 172 and 312 grams. So that is equal to number of animals multiplied with this probability that we have obtained as 0.9502, and this turns out to be 950. And you can see this is 950.2, but if I round off, this is going to be 950. So approximately there are 950 animals whose weight is below 172 and 312 grams. And you can cross check if you add all these values. In first part we obtain 36 animals whose weight is below 172 grams. In second part we obtain 14 animals whose weight is above 312 grams, and now we have 950 animals whose weight is between 172 and 312 grams. Here we have this type of probabilities. Here weight is above 312 grams and here weight is below 172 grams. So there are 36 animals whose weight is below 172 grams, 14 animals having weight above 312 grams, and 950 animals whose weight is below 172 and 312 grams. And if you add all this, you can see you will get total number of animals. So you can just cross verify whether your calculations are correct or not, and this is very easy problem. It is already specified that you have to use normal distribution. So all you have to do is you have to find out the corresponding standard Z values and use your normal probability table. And before that you have to write your probabilities in such a way that you can use these table values, because here table values are in this form: area between 0 and Z. So we are given the probabilities of this type in this table. So we have to use the symmetry of standard normal curve, and we have to rewrite the probabilities in such a way that we can use the standard normal probability table. So this is nice problem, and we stop here. We will continue with this series in upcoming lectures. Thanks for watching.